Hello, this is Mr. Coates, and this is APES lecture number 49, the effects of ozone depletion and some good news about ozone. So one of the concepts I want to get across is that the effects of ozone depletion aren't only human-based, but they're also food web-based or ecosystem-based. If we have high concentrations of phytoplankton in the Antarctic oceans and we have that seasonal thinning during the warmer months down there when the actual phytoplankton are actually increasing, that means we have more UV hitting the Arctic Ocean. And remember we said that UV can mutate cells and mutate DNA. If we have this phytoplankton, and remember phytoplankton is the base of the food chain in oceanic systems, we have this phytoplankton that's getting affected negatively by the UV radiation and will probably start to deteriorate and die off, then the rest of the entire food chain that this phytoplankton is based on will collapse. And so this is a reason why ozone is really important in the role of the Antarctic food web in the South Pole. Let's talk about some other effects of ozone. If we look at a graph, this is a graph of UV radiation in Australia, and it's in two cities here in Australia. What this shows us is that the ozone layer here was thinning over this period from 1975 all the way to about 1999. It looks like that is about the point where we had our lowest ozone levels. As we went on, then ozone started to increase, and we'll get to that a little bit later of why that happened. But if we also correlate that to UV exposure, and they just were able to start actually reading UV at this point. This is all based on models here. But if we look at this point and look on, we can see that at the time of the lowest amount of ozone, the highest amount of UV radiation in these Australian cities happened. And then as the ozone increased, the UV exposure went down. So this is a clear sign of how ozone is related to the UV exposure of these different cities. Remember, Sydney here, which is this purple line here, is actually the further south city in this list. And so obviously it would have the highest amount of UV because it's closer to that thinning area of the ozone. Now, excess exposure to this UV, and particularly UVB rays, are responsible for skin cancers. Malignant melanoma, basal carcinomas, and things like this. These are types of skin cancers that can be contracted by too much UVA and B exposure. UVA and B exposure can also suppress your immune system. They can also increase cataracts, and also, as everybody knows around here, increase the severity of sunburns. If you get sunburned a lot, that could be a sign of future skin cancer issues. So you really want to protect yourself. Other effects that we looked at, this is one of those malignant melanomas that I talked about. This is a cataract down here. The lens of the eye actually gets cloudy and you have to have a surgery in order to fix that. And then we mentioned increased sunburns here. But also we could have increased photochemical smog. Remember, photochemical smog needs VOCs and NOx and UV light. And if we have more UV light, that means we could potentially make more photochemical smog here. Also, a lot of the paints and plastics and other materials that we use outdoor are highly sensitive to UV light, and the amount of UV light will actually start breaking these things down. For example, PVC pipe. If you have any of the white PVC pipe outside and exposed to the sun, eventually this will become very brittle and crack very easily. And so any outside PVC pipe really needs to be protected with some kind of coating in order to shield it from that UV light. Also, paints on your house. You have to repaint your house every so often because these paints start getting degraded by the amount of UV exposure. Carpets in houses, in areas where you don't have very good windows, the windows will let UV in and it will start lightening the carpets and the blinds and upholsteries in the house, and you'll get a fading of those colors because of UV exposure. So UV can be quite a damaging thing if it gets too high. So how can you reduce your UV exposure? Well, one of the things you can do is just stay out of the sun. The sun is usually its most powerful between 10 a.m. and 3 p.m. and this is when you would get the strongest UV rays. And so if you just stay inside, that's a good way to avoid it. You can also wear sunscreen. Its best sunscreen is usually an SPF of 15 or above, and even 30 and above would be the best. And remember, if you're swimming a lot or you're around water a lot with sunscreen on, it's best to reapply quite often because it will wash off. By doing that, you can really avoid getting sunburned severely, and if you do it enough times, you will get a fairly nice tan. So protect yourself as much as you can. Also, you can wear protective clothing. There's clothing that are coming out now that are very good at shielding UV rays, and you can find that clothing at most decent stores and sporting goods stores. The other thing you can do is avoid some when you're taking certain medications. Certain medications tend to make your body more susceptible to UV radiation. So if you're taking some kind of medication, make sure that it doesn't have on the label to stay out of the sun. Also, avoid tanning beds. Tanning beds have become the #1 cause of skin cancer in most teenagers nowadays. In 2003, a study found that if you use a tanning bed on a regular basis, you're 55% more likely to get skin cancer. Tanning beds tend to have no filtration on them at all. You're directly put in the UV light. A lot of people don't wear sunscreen because it makes the tanning bed all slimy, and tanning beds have just become really bad. In fact, there have been local laws made now for tanning beds, and you have to be 18 at least, I think, in order to use a tanning bed without a parent's consent. So tanning beds are not a good way to go. For example, this lady here, I forget where she's from, but she made news last year where she actually uses tanning beds on a regular basis. You can see how tan and almost leather-like her skin is here, and how white her hair is from the UV exposure. But she actually took her 4-year-old daughter to the tanning bed with her and put her in the tanning bed. And her 4-year-old daughter got very sunburned because of it. And she got in huge trouble with government because of this. It almost bordered on child abuse. Also, you can conduct regular skin examinations. Look for any kind of moles or warts that are changing color and changing shape. If you see something like that, it's best to go and have your doctor look at it. Sometimes it may not be anything, but you never know. And the earlier you catch it, the better off you're going to be. Now, there is some good news when it comes to ozone, and it's very rare we find a lot of good news in this class, but one of the good news is that the world got together and really realized that there was a problem with ozone thinning, and this was going to be a worldwide problem. So in 1987, a bunch of nations got together at Montreal, and they basically put together this treaty known as the Montreal Protocol. And the goal of the Montreal Protocol was to cut emissions of CFCs, those chlorofluorocarbons, by 35% by the year 2000. And because of this, CFC production fell by 85% in approximately 10 years. A lot of the chemicals we talked about previously, their actual use and their prevalence has really dropped. You used to find CFCs in hairspray and spray paint. Anything that came in a can that sprayed typically had CFCs in it as the type of propellant. And that is really cut down. If you look at a can of hairspray nowadays, it'll have a little symbol on it saying contains no CFCs. So that's really good. Later on, another treaty was signed called the Copenhagen Protocol, which actually sped this up in order to make it happen faster. And if we look here, from 1989 to 2009, the amount of CFCs being used worldwide has significantly dropped. And that is huge news, and it's one of the shining examples of where the globe actually got together, saw there was a problem, and did something about it, and made great strides in correcting this so our ozone layer would not continue to degrade. So the question is, and I posed this earlier, is the ozone thinning area getting smaller? Well, let's take a look here. So this is different times in Septembers of the ozone thinning area over Antarctic, and you can see it's different for a lot of different years. In September 2006 we had quite a large hole, as well as 2007. However, in 2008 it wasn't that bad, as well as 2010 in September it wasn't that bad. 2009 a little bit better than some of these other years. And then we saw the previous one in 2014, which had a fairly significant hole. So it's hard to say if the actual ozone thinning area is getting smaller, but I think for the most part it is starting to get smaller, but it's going to take time for the ozone layer to naturally repair itself. And realize we haven't gotten rid of all of the CFCs yet. We're still putting CFCs out there, and they will continue to do damage until all of them are gone. Well, I hope this answers questions about the effects and also the good news that relates to ozone. If you have any questions, please bring them to class.